Okay, this is lesson 110. We are converting repeating decimals into fractions. Okay, and your objective is right here. So let's go ahead and get started with it. Here's an example. We want to convert 0.16 repeating to a fraction. Okay, and the reason that we would want to do that is because we talked about this. Repeating decimals are hard to work with. They give us approximate answers. Okay, they give us answers that we have to round if we want to multiply or divide, okay, or anything like that. So, the only way that we can get exact answers is to convert them to fractions first. Okay, so we have to have a method to do that. Now what we're going to do, okay, is we're going to say that x is equal to 0.16 repeating. Okay? Again, x is equal to 0.16 repeating. Now, what we can do is then, if I have 1x is equal to 0.16 repeating, what we're going to do is we're going to multiply that by 10, okay? And the reason why we're going to multiply it by 10 is because there's one repeating decimal here, okay? One repeating place. If there were two repeating places, then we would multiply it by 100. If there were three, we would multiply it by 1,000, okay? But when there's one repeating decimal place, we're going to multiply this number by 10, and we're going to call it 10x. Okay, because x times 10 is 10x. So if x is 0.16 repeating, then 10x is going to be 1.6 repeating. Okay, because all we're doing is moving this decimal over 1, so we multiply by 10. So it's 1.6 repeating. Okay, so now what we're going to do is we're going to take the second equation, and we're going to subtract the first equation from it. Okay, we're going to take the second equation minus the first equation and solve for x afterwards. Okay? So let's take a look at what this looks like now. So my second equation is right here. That's 10x equals 1.6 repeating. Okay? Now if I look at this, okay, if I put the second equation underneath it, that is 0.16 repeating. What we need to do, remember, is line up the decimals. Okay? So it's 0.16 repeating. Okay? Now the reason why I didn't put the repeating bar above this one is because I knew I was going to need one extra decimal place here. Okay? Because I have two decimal places in this number, I have to have two decimal places in this number. So this is 0.6 repeating, which means there's another 6 that goes afterwards. Okay, a lot of times we would add a 0 here, but since this repeats, we have to add another 6 and put the repeating bar above it. Okay? Well, what's going to happen here is now we've got a subtraction problem. And we're going to subtract like terms. 10x minus x is 9x's. And then 1.66 repeating minus 0.16 repeating. What happens is these just cancel each other out because 0.6 repeating minus 0.6 repeating equals 0. So these will cancel. And that's what we want to have happen. So now look what happened. We don't have any more repeating decimals there. Okay, and that's a very good thing. So now we're going to subtract these. 1.6 minus 0.1 is 1.5. Okay? And if I divide by 9, okay, I'm going to get x equals 1.5 over 9. Okay? Well, now I can't leave a decimal on top of here, so I got to think, okay, what can I multiply this by? Okay, to make it not a decimal. Well, if I multiply it by 2, 1.5 times 2 is 3. So I'm going to multiply this by 2 over 2. Okay, and the reason why I can multiply by 2 over 2 is because what's that the same as? 2 over 2 is the same as 1. And when I multiply any number by 1, it doesn't change its value. Okay, again, I'm using kind of the common denominator thing, where we would multiply to find a common denominator. So I'm multiplying the top and the bottom by 2. And what's going to happen is 1.5 times 2 is 3, and 9 times 2 is 18. So we get x equals 3 over 18. And that's my answer. Okay, 0.16, the 6 repeating, is 3 over 18. Okay? Now let's do another example. Here it says the theoretical probability of rolling a 12 with two number cubes is 0.027 with the 7 repeating. Okay, but how many times would you expect to roll a 12 in 180 rolls? Alright, well, the very first thing we do is, again, we can't work with repeating decimals, so I need to change this to a fraction. Okay, so I'm going to do that whole first equation, second equation thing. So I'm going to set x equal to 0.027 repeating. Again, the reason for that is because we work with probabilities. A lot of times we work with fractions, okay, unless they're terminating decimals, means decimals that stop. But this one repeats, so we need to make it fraction form. And again, I've got one repeating decimal here, so I'm going to multiply this whole equation by 10 and say that 10x's is equal to, and then if I move this decimal once, I'm going to get 0.27 repeating. Alright, so 0.27 repeating. Now again, I'm going to subtract the two equations. So I'm going to take the second equation, okay, and put it on top. And now I'm going to write 7 repeating. The reason for that is because this number has 3 decimal places. So to be able to subtract them, I need to have 3 decimal places with this number now. So I just put an extra 7, and I know it's still going to repeat itself. Okay, so this number is the same as this. Okay, because this 7 is going to keep going forever still. And then I'm going to take away the first equation. Okay, and again, 10x minus x is 9x's. And look at here, these 0.7 repeatings right here cancel each other out because they make 0. So I'm going to get 0.25. Okay, and then again, divide by 9. And I get x equals 0.25 over 9. Alright? So now, again, I have to get rid of this decimal on the top. So I have to think, what can I multiply 0.25 by to get a whole number? Okay, now one option I have is I can multiply it by 100, because that would just move this decimal over twice. Okay, but I also know that 0.25 times 4 gives me 1. Okay, and that's a whole number. So I'm going to take 0.25 over 9 times 4 over 4. Okay, because 0.25 times 4 is 1, and 9 times 4 is 36. Okay, so I've got a 1 out of 36 chance of this happening. Now the problem asks me, how many times would you expect to roll a 12 in 180 rolls? So I want to know, if I get 1 out of every 36, I want to know how many times out of 180 would I get it. Okay, so we're going to solve that by cross multiplying. And 36 times x equals 180. Oops, 36x equals 180. Then if I divide by 36, okay, 180 divided by 36 equals 5. So my answer is 5 times. I could expect that to happen out of 180 rolls, if it's 1 out of every 36. Alright, and I got one last example for you. Bonus example. Okay, this is my favorite example of the whole bunch, the whole reason why I even wanted to do this lesson. Okay, let's convert 0.9 repeating into a fraction. So again, we're going to do x equals 0.9 repeating. Then I'm going to multiply it by 10 and say that 10x's equals, again, if I move this decimal over once, what's going to happen here? Well, let's think about this. This is really 0.9999, so on and so forth. If I move the decimal over once, I'm going to get 9.9999, or 9.9 repeating. Okay, by moving the decimal over once when I multiply it by 10. So now again, I'm going to take the top equation, 10x equals 9.9 repeating. The reason why I'm putting the bar above this one already is because I have one decimal place here and one decimal place here already. Okay, so I don't have to change much. And then I'm going to subtract this first equation, 0.9 repeating, and 10x minus x is 9x. Then these 9's cancel out, the 9 repeatings, and 9 minus 0 is 9. Okay? Well, now if I go ahead and solve this, I get x equals 1. Okay? So 0.9 repeating to a fraction is 1. Okay? And that blows a lot of people's minds, is how can 0.9 repeating actually equals 1? Okay? But we proved it right here. Okay? And there's another way to prove that. Let's think about this. Think about 1/3 as a decimal. That's 0.3 repeating. 2/3 as a decimal is 0.6 repeating. So then what would 3/3 have to be? Okay, if I go 1/3, 2/3, 3/3, that's a pattern. Well, 0.3 repeating, 0.6 repeating, and 0.9 repeating would equal 3/3. And 3/3 is the same as 1. Okay, so again, that blows a lot of people's minds who don't know much about math, that 0.9 repeating can equal 1. Okay, and I've always thought that was cool. Alright, that's your lesson on changing repeating decimals to fractions. Happy homeworking.